Hello everyone. In this series of crash course, today we will be discussing about states of matter chapter. Here I will take a small topic of diffusion and effusion. Now what happens up in this diffusion and effusion? See, diffusion and effusion, what happens? See, the first thing is diffusion. What is diffusion? Diffusion, I will tell you in simple words. What does it mean? For example, we are having up one chamber of gas. One chamber of gas is there. Here there is a partition. Here there is a partition. Okay. And over here in this we are having up a certain gases. One gas is over here. One gas is over here and one small gas is here. Clear? Now what happens up? If you take out this partition, here, these gases will start moving from left to right and they will start moving from right to left. Okay. So what will happen up here in this case? Here, see this, clear? These gases will start moving from one point to another point. Okay. This intermixing of gas, this intermixing of gas is called as diffusion. So means we are having up a chamber of gas, we are taking out a partition, one gas on the left hand side will come to right hand side, the gas on the right hand side will come to left hand side, or always the gas will always move from a higher concentration to lower concentration. Okay. So there is a higher concentration on this side for this gas, so it will move towards this side. There is a higher concentration of this small gas on right hand side, so it will come to this side. So this phenomena or this method is totally called as a diffusion. Clear? Now this is diffusion. Now what happens up in next case? Here we will see rate of diffusion. What is rate of diffusion? See, we are having up a gas. Okay, this gas is moving from left to right or it is moving from right to left. If it is moving, it must be having up a certain speed or it must be having up a certain rate. That rate of diffusion, is experimentally it has been found that rate of diffusion is inversely proportional to 1 by root of molecular mass of gas. Clear? The rate of diffusion is inversely proportional to 1 by root of molecular mass of gas. We can also write, see, we know that density of any gas or anything is always equals to mass divided by volume. Density is always directly proportional to mass divided by volume. So density will be directly proportional to mass. Okay. What I can write here, I can take out this molecular mass. Instead of it, I can put up a inversely proportional to 1 by root of density of gas. It is 1 by root of density of gas. Now what happens up here in this case? See what will happen up next thing. Next thing is Graham's law of diffusion. See, scientist Graham has done up a research on diffusion. So he has found something like this, which we have discussed, like rate of a diffusion is inversely proportional to the molecular mass. Rate of the diffusion is inversely proportional to the density of gas at constant temperature and pressure. See, we'll always, this external things like pressure, temperature, these all things will be constant, then only these laws will be working up over here. So what we can write, that the constant temperature rate of diffusion is proportional to pressure, is proportional. It is proportional to pressure divided by root of a density. Now what happens? See, there is one more thing we can discuss in this case. That thing is, here we can discuss up a, see, for example, I am having up a chamber of gas. This chamber of gas, okay, here in this chamber of gas, here the volume of the chamber is something V, the amount of gas is something V. Okay. Now this gas on the left hand side is going to move on the right hand side. The right hand side gas is going to move on the left hand side. Okay. Now we will find how much time will it take for this gas to come over here, and how much time will it take for this gas to come over here. The left hand side gas will move to right hand side, the right hand side gas will move to left hand side. They are finding out how much time it will take. So we will write here time of diffusion. time of diffusion is always directly equals to volume of gas divided by rate of diffusion. Okay, or let us write completely, volume of gas divided by rate of diffusion. Now volume of gas divided by rate of diffusion, see volume of gas you can take it V. Rate of diffusion is, what is rate of diffusion? It is something K divided by root of molecular mass. K is any constant. Okay, K is any constant. So what I can write here, see if I write it on this side. So the time of diffusion is equals to something V into root of molecular mass divided by K, or time of diffusion is directly proportional to root of molecular mass. Is it clear? So the time of diffusion is directly proportional to root of molecular mass. Rate of diffusion is inversely proportional to molecular mass. Okay, basis on these we will do up certain numerical. Okay, but before this, see, like diffusion is there. What is diffusion? It is intermixing of gas. Okay, or the speed of intermixing. Sorry, it is the intermixing of gas with each other. Now we will come to effusion. Effusion is, okay, for example, any gas is passing through a orifice, like one chamber of gas. This chamber of gas is also having up a gas particles over here. Now what happens up here in this case? See, if you take out here, now for example, in this gas, here this gas, okay, let us draw up another chamber. One chamber is there. This is having up a orifice. A small hole. And here we are having up a gas. Here we are having up a gas. Now when here we are having up a gas, this gas will always try to move out of the system. This will always try to move out of the system. This process of moving out of a gas through a orifice or a hole is called as a effusion. So this process is effusion. Moving of a gas out of a orifice is effusion. Intermixing of a gas is diffusion. Now what happens up here in this case? See, effusion is there. Now see, rate of effusion is also inversely proportional to 1 by root of molecular mass. Rate of effusion is also equals to 1 by root of molecular mass. Okay. Now see, the rate of effusion is inversely proportional to 1 by molecular mass of gas. Same, rate of effusion is also inversely proportional to 1 by root of density. Same, the whatever formulas we have used in diffusion, the same formulas will be used up in effusion. Time of effusion will also be directly proportional to root of molecular mass. Okay. So the same thing or same formulas we will be using up in everything. Clear? Now the next thing which comes up here, now we will do one numerical on this. Okay, on the basis of whatever formulas we have derived just now. 50 ml of hydrogen diffuses through a small hole from vessel in 20 minutes time. Time taken for 40 ml of oxygen to diffuse out under similar condition. See, this is a numerical of what they are telling, diffuses through a small hole. Diffuses through a small hole means they are talking over here of a effusion. We know rate of effusion, okay, or the time of effusion is equals to volume of gas divided by rate of effusion. Okay. Now what happens up here? We are having two gases. One is dihydrogen H2, another is O2. So time of effusion of O2 is equals to volume of O2 divided by rate of effusion of O2. Now, if you divide it by time of effusion of H2 is equals to volume of H2 divided by rate of effusion of H2. Clear? Now volume, what they have taken up? See, 50 ml of hydrogen, dihydrogen. So volume of H2 is 50 ml. We'll put up these all values over here. See, what is the time of effusion of O2? Time taken for 40 ml of effusion. Okay, they are asking up time of effusion of O2. Time of effusion of H2 is 20 minutes. Okay, so here time of effusion of O2 divided by 20 minutes. This is equals to, now volume of O2. What is the volume of O2? Volume of O2 is 40 ml divided by, what is rate of effusion of O2? Rate of effusion will be inversely proportional to the mass. So we'll write it here, K root molecular mass of O2. Molecular mass of O2 is, what is the molecular mass of O2? Molecular mass of O2 is 32 divided by, what is the volume of H2? Volume of H2 is 50 ml. 50 ml divided by K root of what is O2? What is the molecular mass of H2? It is 2. So K to K will get cancelled. This to this will get cancelled. Root 2 to root this will get cancelled. This will be root 16. Root 16 is 4. So it is 4 into 4 divided by 5. This is equals to, so this is 4. Here the answer will be 4 into 4 into 4, 64. So time of effusion of O2 will be equals to 64 minutes. This will be the answer. Is it clear? So one numerical on effusion we have done. Now again one more numerical we can do. If the 4 tubes of a car are filled to the same pressure with N2, O2, H2, CO2 separately, then which one will be filled first? Actually what they are doing up, they are having up 4 different pipes. Okay, let us draw up one pipe. They are having up a 4 different pipe, and here they are putting up a gas into this. When they'll put up a gas, so this, how does this gas will go? This gas will go to this through some pipe. So this is a numerical of again effusion. Again this is a numerical of effusion. Now see, that tire will be filled first, for which this gas will pass through this hole very easily or very fast. Okay, so means which one? We know that rate of effusion is inversely proportional to root of molecular mass. So rate of effusion, which will be having up a highest? See, N2 molecular mass is 28, O2 molecular mass is 32, H2 molecular mass is 2, CO2 molecular mass is 44. Clear? We know rate of effusion is inversely proportional to molecular mass. Okay, so we'll arrange in order of rate of effusion. Rate of effusion, it is inversely proportional to molecular mass. So which will be having up a highest molecular mass? H2 will be having up a, see, first we'll arrange in order of molecular mass. Molecular mass is, which is having highest? CO2 is having highest, then it comes O2, then it comes N2, then it comes H2. This is molecular mass. Okay. Now rate of effusion, which is having up a rate of effusion? High, opposite. It means my H2 can be filled in the fastest way. And what they are asking, which separately, which will be filled first? So H2 is having up a highest rate of effusion. So the tire in which we are filling up a hydrogen will be filled very fast. So what will happen? This will be our correct answer. Okay. So we'll finish up over here in this lecture. We'll meet up in next lecture with some other topic. That's all for the day. Thank you.